All right, so good afternoon, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we're all about bringing conservation, adventure, and science into classrooms around the world. This week is our Space Week, which we're super excited about. We've got over 30 hangouts with amazing space explorers, engineers, doctors, all sorts of people from around the world. So we're really excited to share that with classes today. Today is our last hangout of the day, and we've got four classes from across North America. Just popped in, so I'm going to give them a chance to do a bit of a shout out. We've got Mrs. White's grade 6 class in Barrie, Ontario.
We'll be a bit more still.
We're getting there. Coming in. That's exciting, though. Okay. We've got Mr. Kaplan's grade 6s in Hillsborough, New Jersey. All right, setting the bar high on excitement. We've got Mr. Waterworth's grade 6-7s from Sarnia, Ontario. Hello, the mic's not working, but we're totally good anyway. All right. And we've got Mrs. Fletcher's grade 6s in Cambridge, Ontario. It's very high-pitched. Okay. Of course, the reason you guys are all here today is for our amazing speaker. We're joined live by Jamie Sevigny, an engineer and former robotics instructor at the Canadian Space Agency. So she's our first Canadian Space Agency person for Space Week, so we're super excited about that. She got to boss around astronauts and tell them what to do and using Canon Arm too. And currently she's a project manager on the RADARSAT Constellation Mission, which she's going to tell us a little bit more about in a second. So without further ado, thank you so much for joining us, Jamie.
Thank you. I'm very happy to be here, and thanks for the invitation. Yes, I'm an engineer at the Canadian Space Agency. It's really an honor to be the first one from the Canadian Space Agency. I wasn't aware of that. So I'll try to set the bar high, just like the other classes did with their noise and their energy. 15 years ago, actually a bit more than 15 years ago, I was hired as an engineer at the Canadian Space Agency, the CSA. I was hired as a robotics instructor and operations engineer. And so that meant that I needed to, for example, really learn a lot about space robotics and become an expert on it because, as you mentioned earlier, I got to boss around astronauts and tell them how to use space robotics. So we've got a little presentation put together to show you a few images of things of the CSA and of the things I used to do and things I'm working on now. So we're just going to put up that presentation, and I've got some help for that. Let's go ahead. See? Perfect. All right, so you can all see the slides. I hope that's coming in clear. Yep. So here we have a beautiful aerial picture of the CSA headquarters. That's located in Longueuil in Quebec, Canada. There's no cars in the parking lot, which I find very odd. So that must be a weekend, but normally that parking lot is full. We've got about 650 employees working at the CSA. You'll see some neat things there. You'll see a satellite dish. That's a satellite dish that's used to communicate with satellites, namely RADARSAT is one of them that it communicates with. We'll be talking about satellites a bit later in the presentation. In the back, you see it looks like a big sandbox. It is. It's a Mars yard. So CSA also is involved in some Mars rover design, testing, and so on. I don't get to play with the rovers myself, but I have a lot of colleagues who do, and it's a lot of fun. So if we move to the next slide here, my first job at the CSA was training astronauts. So I had to learn about the robotics that are on board the International Space Station. And here's just a quick picture of myself when I had short hair, training our former astronaut Julie Payette. So you might know who Julie Payette is. Here's a picture of the International Space Station. It's beautiful, it's majestic, it's quite huge. It's a partnership. Many different countries put this space station together. And Canada contributed the robotics. So you can see some of the robotics in there. You see a tiny little arm floating in the background. It looks tiny in the image, but it's actually 17 meters long. So if you just try to imagine how long 1 meter is, and then you take 17 of those, so that you can imagine how big that space station is. In fact, it's about the size of a Canadian football field. And to give you an idea of the living space in there, it's the living space of about a 5-story house. So it's pretty majestic. It's pretty impressive. It's pretty wild that all these countries came together, worked together, and sent astronauts there to live and do science in space. Pretty incredible. So that's where I first started at the CSA. Now, to put this whole thing together, I guess they needed some sort of, you could almost call it construction material. I like to compare the Canon Arm sometimes to a big crane. To put all these modules together, they didn't just launch it all up in one shot. They launched it in many, many different pieces. The Canon Arm 2 was the tool. Here's a picture of the Canon Arm 2. Was the tool that they used. Its main purpose was to assemble the space station, the International Space Station. The Canon Arm 2 was launched in, I'm just looking here, it was installed in 2001. I started at the CSA a year later, so the Canon Arm 2 was already on orbit, but somebody had to operate it. So we had to train those people on how to operate the Canon Arm 2. I've got some really interesting pictures to show what the Canon Arm 2 would do. Here we go. The Canon Arm 2 was used to build that big space station. So this is a picture of a truss segment. If you recall that from the previous slide, there was a really long rail. It kind of looked like a train tracks. Well, that's the purpose of one of the purposes of the truss segment. It's to slide. There's a part of the robotics that are on the International Space Station is called the mobile base system, and that was the train that moves the Canon Arm 2 from one end of the space station to another. There's other ways that the Canon Arm 2 can move around the space station, but that was one of them to get from left to the right to right of the station. And it moves along this truss segment. So the Canon Arm 2, if you can see, I don't know if they can see my mouse. No? You can see the Canon Arm 2 in the bottom right of the screen. You can see it's grabbing on to the truss segment, and it's moving the truss segment very, very slowly to connect it to another part of the space station. So it pulled this out of the belly of the space shuttle. The space shuttle is no longer flying, but that's how we would get some of these really large pieces up into the space station to put them together. So the Canon Arm 2 would go in and would help install it. Here's another example of a module that the Canon Arm 2 would come in and just a beautiful picture. This is a Quest module. This is a module that the astronauts would use. They would sit in there and sleep in there before they would go out in spacewalks. So here's another big, big, heavy, massive piece that the Canon Arm 2 would come and grab, and then it would install it onto the space station. This is beautiful. So we have a few of these pictures. If you go on the internet, you'll see some pictures like this. The Canon Arm 2 was not only used to build the space station, the International Space Station, the ISS, it was also used to help the astronauts when they would go outside of the space station on a spacewalk. They could use the Canon Arm 2 to move the astronauts around the outside of the space station. And so this is a beautiful picture of the Canon Arm doing just that. So it would help them out with the work that they would do outside of the space station. And then later on, here's a picture of a Dragon. This is a SpaceX Dragon. This is it looks very calm, a very calm picture, a beautiful picture. But the astronauts who would be operating the Canon Arm 2 for this, believe it or not, they would have to go in and capture a floating object. So the object would be floating in the air, and the Canon Arm 2 would have to come in and grab it, and there would be somebody operating the Canon Arm 2 in order to go grab it and then install it onto the space station. So who would operate the Canon Arm 2? Well, the astronauts in the beginning, in the early days, the astronauts would often be the only ones operating the Canon Arm 2. They would come up to the Canadian Space Agency for 2 weeks of training. They would get some general robotics training. They would get some specific training on the Canon Arm 2, on the mobile base, how everything worked. So they would have engineers like myself and my colleagues, and we would provide them with some classroom theory lessons. We would tell them what they were allowed to do with the arm, what they were not allowed to do. We would teach them how to safely operate the arm, because remember, it's not Operating the Canadarm2 is not like driving a car. When you're driving a car, you're looking out the windows and you're seeing where you're going. But when you're operating the Canadarm2, you can't just look out of a window to see where it's going. Instead, there's cameras that are located all around the International Space Station, and there's some cameras on the arm itself. And so they would have to strategically place these cameras, and so they would look and point them in the direction of where the Canadarm2 is moving. So we would have to teach them tips, techniques, and safe ways of moving the arm so that it wouldn't collide with structure, so that if it's holding that big truss segment or the big Quest module or this Dragon, it wouldn't accidentally crash it into the space station. So we had a team up here who would train astronauts, and we still do have a team who trains astronauts. However, nowadays, a lot of the operations of the Canadarm2, a lot of it is done from the ground. So there's a lot of computer commands that are sent up to the arm in order to move it. And so by doing that, they save the astronauts a lot of time so that they can devote a lot of their time, more of their time to science, to maintenance within the space station, and so on. So I think the next picture, we have a good idea of the mobile base. So here you have a picture. The Canadarm2 is sitting on, this is the mobile base system. It's anchored onto one of its base anchors, and that mobile base can slide back and forth along the International Space Station, just to give you an idea, along that truss segment. You also see a couple of astronauts in that picture. It's almost like a Where's Waldo because they fit in with the structure. They're all white. Later on, Dexter, our two-armed robot, was sent up to the International Space Station, and Dexter had a very different role than the Canadarm2. So the Canadarm2 provided, it was a big tool to build the space station. It helped out the astronauts. It caught free flyers. It also provided camera views if they ever needed to inspect anything on the space station. But Dexter was sent, and the reason he has his name is because it did dexterous operations. So dexterous operations, that means very fine, very, I guess, detailed operations. They get into close quarters. They go and grab onto things, and they also have tools. So the purpose of Dexter was to almost like replace a spare tire on a car. Dexter was there to replace failed boxes, failed modules, failed electronics units on the outside of the space station. So rather than sending an astronaut on the outside of the space station where it's quite dangerous, it's a hostile environment, instead they designed and built this robot with two arms, very similar to a human. It kind of looks human-like, to go and do these tasks for the astronauts, because the space station, it's not young anymore. And we know, just like with our car, things break and you have to replace them. So in this case, instead of sending an astronaut out, the Canadarm2, it would come along and it would grab Dexter, just as we see in this picture. It would maneuver Dexter around to an area where maybe an electronics box needed replacing. And then with one arm, it would grab the old replacement unit, the old unit that's broken and has to be replaced. And in the other hand, it would have a new unit, and it would go and it would install the new unit. So Dexter was it's still operating. Dexter is a very useful robot that helps the astronauts be able to use their time inside the space station, because there's a lot, I guess with time, things wear down and you need to replace them. And so Dexter's been put up there for that. And again, Dexter, less and less, it's not the astronauts who are operating Dexter robotic operations. Instead, it's engineers that are on the ground. So the Canadian Space Agency is involved in those operations along with NASA. So we work together to make sure that the right commands get sent to the robots on the International Space Station to do the tasks that they're assigned to do. I think. So that's what I did for, I think it was for 8 years. I was training astronauts. I was training mission controllers, so the engineers who are on the ground, as well as capsule communicators, so those the people who communicate with the astronauts that are on board the space station. So we would train them all about those robotics operations. And then in 2010, I switched over to more of a project side. So rather than being in the operations, I went over to the side where it's the beginning of the projects, the decisions that are made. How do projects get put together? How do we decide? For example, in the case of Canon Arm 2, it had to be designed at some point. People had to make the decisions. So I'm more on the project side now. And the project that I'm working on is an Earth observation satellite. So we've got a neat picture here of some satellites where CSA is either the lead or CSA has contributed some instruments. So we do a lot, and we do a lot of partnerships. We do a lot of projects where there's a lot of Earth observation, there's atmospheric samples being taken. And if you look at the bottom left, I think I have another picture though, we see the 3 RADARSAT satellites, and I'll explain to you what they are. So these are 3 satellites. They're going to be launched in 2018. These satellites are imaging the Earth. Right now in the picture, they look side by side, but they're not going to be side by side. They're going to be a bit more spaced out. They're not taking a picture of the Earth like your camera does. Instead, they're sending microwaves down, and then they measure the signal that comes back. And with those types of images, we're able to detect ships in the water, so to protect our coastlines. We're able to detect icebergs, so for safety reasons and for our ships to be able to navigate in the northern waters. They're very, very useful for detecting where the icebergs are. They're able to see oil in the water, so if there's a big oil spill, they can help with cleaning up oil spills. They're good for crop monitoring. They're good for so many things. So these 3 satellites are going to be used for a multitude of purposes, and they're going to be doing that by looking at our Earth and sending the images down to us. So I'm on the team that's getting the ground segment, so all the computers and all of the antennas on the ground that have to be ready in order to communicate with the satellites when they're in orbit, when they're going around the Earth. I'm part of the team that's putting together that, and it's called the ground segment. So we've got here some recent pictures. So this is a picture of one of the satellites, so you can get an idea of how big it is. This was at our David, Florida laboratories. So CSA also has those laboratories in Ottawa where we do some testing of satellites. And we have a big TVAC chamber, so that's thermal vacuum chamber. So this is necessary testing before you send a satellite into orbit. And to give you an idea, I kept the image with all the people so you could see how I'll say big the satellite is, but in fact, it's a really small satellite. And here's another one at the end of its testing. It successfully passed all of its tests. And you can see we've got the big CSA logo there. We're pretty proud. And we've got the DFL, stands for the David, Florida Laboratories. So we're getting close, launching in around a year. And hopefully then we'll start seeing some images from these 3 satellites being used. That's all.
Excellent. Well, thank you so much for that. What a wonderful presentation. All right, so now question and answer time. So what we'll do is we'll go through classes one by one, and then they can ask you some questions. We also have a few groups that are watching online. If they want to submit questions in the YouTube chat bar, I can pass them along to Jamie. So feel free to do that.
Sounds good.
Right. Let's start with this White's class. If you guys have a question, come on up.
In your opinion, what is the most important robot on the International Space Station?
The most important robot? Oh, that's a good question. Well, I'm Canadian, so I have a bit of a bias because there's other robots up there too. Part of me would want to say Canon Arm 2, because without the Canon Arm 2, you would not have been able to build the International Space Station, and so you would not have the International Space Station. But then the other part of me wants to say that Dexter is equally as important, because when something breaks down on the outside of the space station, if you can't replace it, then eventually we're not going to be able to send astronauts up to the International Space Station if the space station itself is not healthy and if it's not functioning properly. So I have a little bit of a bias. I really like that big 17-meter long arm.
Bias granted, but it's a good thing to have a bias for. What a great thing. All right, let's go to Mr. Kaplan's class. If you guys have a question. Does anyone have a question?
Yeah, he's coming up now.
Perfect. Go ahead. Yeah.
I think we may have forgotten our question.
We can come back. We'll come back to you in a minute. We promise. All right. Let's go to Mr. Waterworth's class then. Go for it. Oh, mic's not working.
Didn't hear it.
No. I don't know if your mic's working, guys. If not, you can always write it in. That's the worst case. Try now? No. Sorry. Okay, so we'll come back to you too. Right, we'll be right back. Mrs. Fletcher's class, you guys are there anyway. Come on up. If you guys have a question, go right ahead. Let's just mute that mic. And
other space.
There you go. Yep, you're good.
That's what your question. What does the Earth look like? Mine was.
Hard to hear the question in the class, guys, so loud.
What was your question?
What does the Earth look like from space?
What does the Earth look like from space?
All right. So I haven't been out to space, so I couldn't speak from my own personal experience. But depending on where you are in space, the Earth looks very different. If you're really, really, really far away, it's going to look like a little blue dot. But there's an insane number of images, of pictures that were taken by astronauts who've been on board the International Space Station. And I really, really recommend that you go take a look. There's some beautiful photos that have been taken. The Earth, it looks small, it looks majestic, it looks, the mountains, they look like mountains, but it's from a completely different angle than you've ever seen them from before.
Great answer. So even if you're not there, you can look at the pictures and get an amazing view of the whole thing.
Yeah.
All right, so Mr. Waterworth's class wrote in and asked, how long have the RADARSAT satellites been being built? Like, how long has the project been?
All right, so the first, there was a first RADARSAT 1, that was launched in November of 1995. So that was a government-owned satellite, and we used a lot of images, and that went well past its expected lifetime of, I think, around 7 years. But it lasted, I think, around 15 years. I don't know if you recall the date. But we currently have, there is a RADARSAT 2 satellite that's in orbit right now, and it's taking images. And RADARSAT Constellation Mission is the one that I'm currently working on of 3 satellites. That's supposed to replace RADARSAT 2, but most likely RADARSAT 2 is still going to be going around and taking images when the RADARSAT Constellation Mission gets launched.
Did they take a few years to build, though? Like, how long, do you know, from the inception to the...
Yeah, so they do take quite a while. Let's see. I'm trying to think back because I've been here for 15 years, and the RCM was I came on board at 2010, and that was in phases BC. So let's just say in the early 2000s, they were probably starting to talk about the RADARSAT Constellation Mission.
Okay, there you go. So
it takes a long time to get these up into orbit.
We can tell. All right, Mr. Kaplan's class, if you guys have a question, someone there.
How many astronauts are in the International Space Station right now?
Oh, you've asked me a good question. I'm not sure right now, but I would like to say that on average, they tend to have around 6 astronauts on board the International Space Station. I'm pretty sure that it can accommodate more than that, but that's the general number that you'll see on board.
Excellent. When's the next Canadian going up?
Oh, David St. Jacques. He's going up in November of 2018. So in fact, RCM is going to be launched right about the same time that David St. Jacques is going to be going to the International Space Station, if everything goes as planned.
Okay, fingers crossed. We'll check back in then for sure.
Great question.
Let's go back through the classes. So Mrs. White's class, if you guys have another question, come on up.
What happened to the Canada Arm 1?
Oh, that's a really good question. So maybe not everyone's aware that there was a Canadarm 1, but Canadarm 1, which we initially called just Canadarm, it was an arm that was part of the shuttle. So the big space shuttle, the big plane that went out into space, it was attached at the shoulder inside the space shuttle. And so when the space shuttles got retired, the Canadarm 1s were no longer used because they were part of the space shuttle.
Are there any places you can see a Canadarm, one of the original ones?
There are. Do you know where they are? There are. I'm pretty sure there are. I think there's a space shuttle on display somewhere, but that you could probably find that on the internet, but I think there is. And it looks different. So the pictures we saw were of the Canadarm 2. It was big, it was robust, but that's because the Canadarm 2 was sent up to the International Space Station and never came down to Earth for repair. Whereas the Canadarm 1 would go up with a space shuttle and would come down with the space shuttle. And so it would be, if there was any need for repairs, it would always come back down Earth for repairs. On the space station, it's a lot more difficult to do repairs. So you would always have redundancy. And that means you always have two of the same type of instrument or computer so that if one breaks, you can always switch to the second one. And then, what did we say about Dexter? Well, it's out there to replace boxes. So if you have a unit that's failed or a computer that's failed, if anything, Dexter could come out and somehow repair it. Maybe not on the Canadarm 2 because it's a bit dependent on the Canadarm 2, but that's the idea of always having these backup boxes, two of everything.
Excellent. Mrs. Fletcher's class, we had a harder time hearing them earlier, so they wrote in a question. And what is the smallest satellite? You're talking about big satellites, small ones. So what's the smallest?
The smallest. I'm probably not the best person to ask about the smallest, but I do know that there are some that are about the size of a suitcase.
Really, eh? Yeah. Okay, what about the biggest? We'll just, we'll cover everything.
Okay, so I probably don't know the biggest. Well, okay, so a satellite, though, is just something that orbits the Earth. And so we might say that the International Space Station is the biggest satellite. But if we're talking about satellites that compare somewhat to RADARSAT, I mean, or if we're just talking about things we send out into space, we also have the Hubble that's quite huge. And the replacement for the Hubble is the James Webb Space Telescope. And I've seen that one, and it's massive. So it's currently going through some testing right now at the Goddard Space Flight Center. That's one of NASA's centers, so it's quite large.
Yeah, and is it going up next year too, or later than that?
I'm not sure.
Let me just check. Oh, 2019 launch date, apparently. Very exciting, though. Great missions coming up very soon. That one's been in the works for a long time. There's a lot of little details and mirrors and calibrations that they have to take care of. All right, let's go try Mr. Waterworth's class again, see if the mic actually works. Sorry. So type it in, and we'll go to, you can, if you have it, yeah, so type it in. We'll get to that in 2 seconds. In the meantime, we got another one from Mrs. Fletcher's class, and then we'll go back to the ones we can hear, which is, what did you go to school for and for how long? Oh, good question. So I studied, I did a Bachelor of Engineering. So I studied electrical engineering. When I was a robotics instructor, I worked with a team of engineers as well. And it was interesting because almost everybody had a different engineering degree. There was mechanical engineering, there was computer engineering, there were many different types of engineers working there. There was even a computer scientist who wasn't necessarily an engineer. And I work with people in this building have masters in engineering and PhDs in engineering. So there's many, many different kinds of degrees that you can have if you're interested in working in the space industry, for example. You don't have to necessarily do aerospace engineering. Excellent. All right, so Mr. Waterworth's class asked, in the pictures of Canadarm, it looked like it had a cloth coating. Does that coating have any purpose? Is there a reason for it? Yeah, that's a good question. So those are thermal blankets. So when you're out, when you're not in the protection of the Earth's atmosphere or in the close to the Earth, you're outside, you're out in outer space, you've got more exposure to extreme cold and extreme heat. So those thermal blankets are helping to keep
all of the electronics at a steady temperature. So there's also radiators inside, keeping everything at a temperature that it can work at. If it gets too cold, your electronics could break. If it gets too hot, same thing. So those are thermal blankets.
Excellent. All right, let's go back to Mrs. White's class for another question.
How long did it take to build the International Space Station?
Ooh, the first module went up in Zarya. So it was a Russian module. I think it was called the Zarya, the Sunrise. It was in the 90s. I'd like to say 1990 something or other. 1992, I can't recall. If you look on the internet, you can even see they've got some really interesting animations of how they built the International Space Station. It starts with the first module, then the second module, and so on, all the way until the picture that I showed you earlier. And it was completed in maybe around 2010-ish, so 15 years to build it, to put all of the pieces together. So you've got living modules, you've got science modules, you've got radiators, so that's for the heat. You've got solar panels that take the energy from the sun and convert it into electricity. You've got so many different parts of the space station.
It's a good problem to have right now, Jamie. There's so many questions being submitted, I can't even keep up. So we're going to go to Mr. Kaplan's first, and then we'll pass along some of the others that have been written. But yeah, if you guys have another question, come on up.
How does it make you feel to know that you're helping design these awesome satellites that you get to see launched into space?
How does it feel? The first word that comes to mind is amazing. I wish that all of you could someday be involved in these types of projects, because the number of people, the number of scientists, engineers, communications to let people know about the project. There's so many different people working on each of these projects, and the feeling to know that you were part of something that gets launched into space and then helps everybody later on, whether it's to help for weather forecasting, whether it's to prevent disasters or to help deal with disasters or flooding. It's an amazing feeling, and I really encourage all of you to see if you can work on some of these projects in the future.
Awesome. All right. I realize that we have a lot of classes in Eastern time, so their class is going to be ending in about 2 minutes. We already had one have to drop out. Is there a way classes can reach you or reach the CSA to ask more questions if they are more curious? Because as I said, we're getting a lot of questions coming in.
There's an address? Okay, so my colleague here, Kemi, is telling me there's an address that they can send their questions to. It's info, I-N-F-O, at... Is it still the old?
Oh no, Canada.
Okay.
Oh no, I don't.
We're not sure. How about, can we send the information to you?
Send it to me, and then I'll pass it along to the classes.
That sounds great.
Perfect. All right. So at the end of every hangout, what we do is I'm going to demute the mic of the class that are still here. So Mrs. White's class, Mrs. Kaplan, Mr. Kaplan, Mrs. Fletcher. If you want to join me in saying a big thank you to Jamie, so thank you so much, Jamie. Screaming there. Okay. So thank you so much. That was wonderful. What a great presentation.
Thank you. And if I could just add that if they are curious to know more, there's so much information that's on the Canadian Space Agency website. It's well organized. If they want to learn about the International Space Station, there's a page dedicated to that, and that takes them to many different links. There's pages dedicated to the different satellites and all the projects that the CSA is working on, even the ones where we're just contributing an instrument to somebody else's satellite mission. The information's there. There's a lot of interesting stuff.
Outstanding. Well, thank you so much for joining us for Space Week for the classes. Thanks for some great questions, guys, and hopefully we'll see you later.